Streaming. So, good morning, guys, and welcome to this live lecture series of work, energy, and power. Today, we have a special session on some special level of questions, quite or not, special topics dealing with pseudo forces and dealing with forces in a proper way, quite or not. This type of questions you might not have seen earlier, but here we are going to do it, and we are going to do it in proper way such that you can understand. Okay. So let's start with one level of easy questions and all. Okay, why or not? Simple question is there. Let's suppose there is a truck. Okay, and in that there is an inclined plane. Why or not? And this inclination is of inclination theta. Got it? Point is uh, this truck is moving with 10 meter per second with respect to ground, and I keep one block on this truck. Okay, and this block is of mass 10 kg. Question is very simple. What is the work done by the normal? Is the work done by normal in 2 seconds with respect to ground? What is the work done by the normal in 2 seconds with respect to ground? Let me check. No, the inclined plane does not have any kind of friction, and this angle is 37 degree. Okay. Okay, let's have a friction on this, or without friction also it will go. No problem is there. Right or not? Any idea? 1600. Let me check. No. So tell me, when what does man will see? I'm asking you with respect to ground. See, in case of the frame of, let's suppose, if I consider a observer in this frame, then with respect to him, let me draw the forces. If I try to draw the forces, how we are going to draw the forces? This is going to be mg, correct? And this is going out to be normal, correct or not? Yes or no? This will be tan g cos 37, sorry, sin 37, and this one will be cos 37. So this, you know that this angle also becomes 37. This is 10g sin 37, and this is 10g cos 37. Basically, with respect to this observer, means in the frame of, in the, अविराज, अविराज सो रहा है क्या? सो तो रहा है, क्वेश्चन नहीं बनाया तूने. In the truck's frame, if you look over there, the block is at rest or not? So this implies that what is the work done? Work done is equal to how much? Zero. But if you look into in the ground frame, the truck travels how much? In the ground frame, the truck is going to travel how much? Displacement is equal to 10 into how much? 20 meters corridor. And ground is going to observe that this 20 meter is traveled along this direction or not. Say me something, yes or no? So basically, this normal, if this is 37, this is also 37. This angle is how much? 53 degrees. So the definitely normal is not perpendicular. Work done will be not zero. Say me something, yes or no? So in the ground frame, although this block is sliding down, means 10 g sin 37 is pulling it down, but you will not feel this 10 g sin 37 from the ground. Why? Because you cannot see it. You will only see that this block is going along right hand side. Are you able to get me or not? So therefore, work done by normal in the ground frame is going to be how much? Simple, normal into displacement into cos 53. Clear or not clear? Normal is how much? 10 g cos 37. Displacement is 20 into cos 53 is 3 by 5. Again, remember that trick to find 37 and 53 degree angle. Okay. If this is 37, opposite of that is 3, 4, 5, and this is what? 53. Same something is no? Clear? Right? Reply. So this is how much? 5 4s are 20. This is 960. This is clear or not clear? Understood? Hmm. So now look over here. Let's try another question. As we are exploring to the depthness of physics, in this, a special type of question is going to appear now. Is it never going to become fully vertical or what? Delete it. Let me take another shape. Ah. So let's suppose there is an hemispherical bowl, void or not, placed like this way. Okay. And what I'm doing is, let me attach frame to it. It's placed something like this. Okay. Void or not? A hemispherical bowl is placed like this. Okay, got it. Yes or no, Rayan? Yes or no, Aviraj? Now look over here. Let's suppose in this I attached one thread to a block of mass M, and here there is a pulley. Here what is attached? Pulley is attached, and from here I am pulling it by a force capital F. Okay. Now this radius of the hemispherical bowl is R. Void or not? This is mass M. Okay. So questions are, so this is point A and this is point B. It says that this is a rough hemispherical bowl attached to a fixed system. Okay, got it or not? So question is saying if the mass is slowly lifted to point B, the mass is slowly lifted to point B, then find first work done by gravity, second question work done by external force, work done by external force on mass M, and third question simply, okay, work done by external force, and last fourth question work done by normal. Do this question first. Do it. So any answer? mgr theta. What is theta over here? To find any work done, what I have told you. First draw FBD. You have to draw one thing FBD. Word or not? Minus mgr. So let me check. And then work done by external force. Fr root 2. Work done by normal. Both the answers are Fr root 2 or just one answer is Fr root 2. Both the answers are Fr root 2 or just one answer is F by F root 2R. दूसरा आंसर of course 2 and 3 are different questions. To do this question, simple idea is there, Ryan, how I am going to do. And this is why I told you that these are very good critical questions I'm going to give right now. Draw the FBD first of all, word or not. So if I try to draw the FBD, let me mark this point differently. This is point A, okay, okay. Uh, Weight of the body will be vertically downwards, that is mg, correct. Direction of friction will be there, and as the body is getting lifted up, this friction will work in opposite direction, and that will be kinetic friction basically. Got it? The third force which is working over here is this tension T, and then another force which is working over here is this normal. Got the idea? So there are total how many forces over here? 4 forces. Now, if I write it in terms of work energy theorem, what yesterday we have learned, yesterday I told one law. Law is very simple, that sum of all the work done, sum of all, whatever force of the world, if you add all those forces, you are going to get what? Just change in kinetic energy. Here also same thing. If we add all these forces, so first equation I'll write work done by how many forces are there on the mass? Tension T plus work done by normal plus work done by mg plus work done by kinetic friction, and on the system there is another external force F, and that is equal to what? Change in kinetic energy. Is that clear or not? But then there is a twist in this problem. The twist is written slowly word over here. What does the word slowly means? The word slowly has a very great meaning in physics. Velocity at each point is constant, not zero. Velocity at each point is constant. Means there are three words. The words are just walking. Means if I use the words just walking, okay, slowly, or if I use the word sliding, just sliding, okay, not sliding, just sliding, then these three words, okay, means that the velocity at each point is going to be what? Constant. And this implies that what? Change in kinetic energy in this scenario will be how much? Zero. So basically this is all thing is just equal to how much? Zero. Are you able to get me or not? This is my work energy theorem for this question. Now, as we are told to find work done by single forces, we are going to simply resolve them. Let us just resolve them. See, I asked you work done by gravity. So, as this mass will travel, look over here. This is mg, and this mass is traveling. Means if you look into the displacement of b, the displacement of b is this. You can say that if this is r, then this displacement is how much? Root 2r. So, for first question, if I try to draw FBD, this is the weight mg, and this is its displacement. How much is its displacement? Root 2r. This is how much? Mg. So how much is the angle between them? This is 90 degree. Look over here, and this is going to be 45. So this angle will be total how much? 135 degree. Say me something, yes or no? Got it? So work done by gravity is simply equal to mg into root 2r cos 135. Cos 135 is minus 1 by root 2. So therefore answer is what? Minus mg. Now you can also remember the first statement which we told about work done, this particular page, that work done is also equal to force into displacement along the point of application of force. You can apply this concept over here also. How? See, mg is over here. If you look into the total displacement of the particle along the point of application of mg, that's in upward direction or not, and that is how much? Just r. Is that clear or not? So I can also say that work done by gravity is gravitational force into the point displacement along point of application, which is how much? R, but it is in opposite direction. So therefore answer is what? Minus mg. Is that clear or not? Is this clear? See, work done is equal to what? Force into displacement along point of application of force. Got it? So look over here. Mg is my what? Force. Displacement along point of application of force means what? Either upward direction or downward direction of mg. Body is reaching till point P. So in that scenario, the total displacement along mg is just r only or not? Tell me yes or no. So it means idea is that I reach till point B, means let's suppose this is the force. Okay, let's suppose this is the force and body does a displacement along this direction. So this displacement will have also a component along this direction or not? Say me something, yes or no? So I can just say that the work done is these two. Is that clear? Are you will get me or not? So here you can see that as mg is there, as there is weight how much? Mg, and the displacement along this direction is how much? Just r. So I can directly put the value as also how much? Just r to find the work done. Are you able to get me or not? Is that clear? So component of this displacement along mg is how much? Just r value. So and that is in opposite direction. So this is why this work done will be written as minus of mg r. Clear? Next question. Work done by external force on mass m. Answer. Aviraj, you are saying something of this question. This is why your concept is not. Work done by external force on mass m. You tell me, guys, first of all, how the work is related. Work is related to that force which is present on the body. Here this force is not present on the body. Is this force is present? So if I write work done by external force on mass m, that is basically undefined. Why it is undefined? Because this force because external force is not directly present on the body. Did you get my point or not? Is this external force is directly present on the mass m? No. Then how come we'll find the work done? Work done is defined for those kind of forces which are present on the particle. Otherwise, you have to apply work energy theorem for the whole system. This is why this theorem is given. Why? Because I can apply it for the whole system. I don't have to consider single particle. I will not have to see that which force or which work done is undefined or which work done is defined. Got the idea or not? So this is why work energy theorem was brought to remove this discrepancy from the work. Is that clear? But if I just say find the work done by the external force. So in the case of work done by the external force, what is going to happen? Simple idea is going to be there. 1 minute. Okay, it's not taking 1 minute. Just let me copy it. And I'll just erase this. So first question done, second question done. Now work done by external force. What is the work done by external force? Simple idea is the balance. See, this external force of the system is taking this point C. Okay, 1 minute. What is happening? Can you hear me, guys? Ah. Is taking this particular point C. Let's suppose this C by a distance over here by how much length? If this ball is pulled like this way, then this one is also going to displace by √2r or not. Say me something is or no. So of course there is a work done by external force on the system, but not on the mass m. Got the idea or not? So did you understood what is the difference between work done by the system and work done by the mass m? Okay. So work done by, if I just write external force, then I have to look for the system. Okay. And that is definitely there, which is F into √2r. Are you able to get me or not? Clear or not clear? Understood? Now, fourth one is what? Work done by the normal. Now, if you look into the normal, if I try to draw the FBD, okay, what you are going to see, like let's suppose if I look for the normal at random time, this is mass m, and this is going to be the direction of tension. So, and I think on YouTube live, some guys are watching it. Like, subscribe, and share, guys. Okay, if you love the content. Now, that is tension. Okay, this will be the direction of friction, and this will be what? Weight mg. This is the scenario at random time, correct? This will be kinetic friction, this will be mg. Send me something else or no? This is mass m, correct? So look over here, means, and this is the direction of displacement. Along this direction, the displacement is there. So you can see that all the time, this normal is perpendicular to our displacement or not. So work done by normal, most of the time, in all the cases of physics, you'll find that the work done by the normal is how much? Zero. Is that clear or not clear? Are you able to get me or not? Clear? So now you can easily write the value of work done by kinetic friction using this equation or not. I know work done by tension. I know work done by normal. I know work done by mg. I know work done by capital F, and that is equal to how much? 0. So you can write the work done by kinetic friction. Is that clear or not? Clear properly? Yes. So let's try the next question. Next question of this series, and I'm a big fan of this question because it judges your concept in a very great way. Okay, if your concepts are of physics are too much clear, then only you will be able to do this question, otherwise not. See, the question is saying, 1 minute. The question is saying, let's suppose on this plane I placed a block of mass 2 kg. Okay, and there are two observers. One, call this as observer B, and another one, there is another observer on the ground who is running, okay, with an acceleration of 2 meter per second square. Got it? And there is an observer B, and the trolley was also accelerating. No, this is 5 meter per second square. Sorry, not 5 meter per second square, and the trolley is also accelerating with an acceleration of 2 meter per second square. Got it or not? Now, question is saying the cart, this is man and this is cart. The cart and man starts accelerating from ground uh, okay, let us write from rest, okay, at t is equal to 0. Right or not? So question is, find the work done by friction. Find the work done by friction on the block as seen by first question. Observer B in t is equal to 2 seconds. Observer A in t is equal to 2 seconds, and an observer on the ground an observer at rest on ground. At t is equal to 2 seconds. 3 questions working on your basic ideas. Tell me, huh? Uh, assume that friction, should we keep the value of friction? 1 minute. Let me check. Friction is not given. Means they are assuming that this 2 kg is at rest. Okay. It's saying that the block does not moves with respect to B. Correct? Okay. Okay. First question, what will be the answer? 0. Work done by observer. So first question, as with respect to observer B, the block is at rest. So this implies work done by friction with respect to B is going to be how much? 0. Is that clear or not clear? Second question then, work done with respect to observer A in T is equal to 2 seconds. Think. अच्छा tell me, see, हमने तो B के वजह से लिख दिया. We wrote with respect to B it is 0. Why it is 0? See, you have to work on that. If I ask you, as soon as I go to another observers, the first task appears that, sir, draw the FBD of this block. As you go to the other observers, you have to draw the FBD. If you look into the mass M, this is mass M, correct? So this mass M is going to get pulled by its own pseudo force. Now pseudo force will be of what? Pseudo force will be with respect to this 2 or with respect to this 5. Pseudo force, it is with respect to the 2. Why? Because it is on that frame itself. Are you able to get me or not? So this is force due to pseudo, and that is mass into frame, acceleration of the frame. Got the idea or not, Balak? And then if there is there, then there will be a static friction working over here, such as to stop the block or not. Same something, yes or no? Now this is going to be how much? F mass into acceleration. Mass is 2 kg, acceleration is how much? 2. So this is how much? 4 Newton. So static friction will be also how much? 4 Newton, such that the block will not slide or not. Same something, yes or no? So now let's suppose this is observer A. Got it. So with respect to observer A, what will happen? Let's see that. See, with respect to observer A, with respect to observer A, the block will slide by how much? Displacement of the block, displacement of observer A will be how much? Half A t a square, which is how much? Half 5 into time how much? 2a square, which is how much meter? 10 meter basically. Correct now? This is how much? 10 meter. Now, if I look displacement of the cart with respect to ground in t is equal to 2 seconds, how much will be that? Yes, that is half a t square, half 2 into 2a square. Basically, how much meter is that? 4 meter. Now, you see that what is going to happen in reality? Basically, if with respect to B it is at rest. Now, if I am looking from A, it is asking work done with respect to observer A in t is equal to 2 seconds. This is also a non-accelerating frame, correct? 5 meter per second square, there is an acceleration of the body. So does this 5 meter per second square will appear as a pseudo force over here? The answer is no. Pseudo force appears on the body with respect to the frame itself, not with respect to any observer. Are you able to get me or not? Let's suppose this 2 kg would have been kept in the frame of A, then this pseudo force would have appeared as 2 into 5. Are you able to get me or not? Is that clear or not clear? Means a particle kept in a frame will feel the pseudo force of that frame itself with respect to which observer? With respect to an observer in the frame. Are you able to get me? But if I look from any other particle, means it's like same thing. Like let's suppose there is a car like this way, and there is some person, and this car is accelerating, and there is another car which is coming behind, and you are looking at this car, and this is also accelerating. So if you look at this car, are you going to feel that this person is going behind? No. Only an passenger in this frame can only see that this person is going behind. Are you able to get me or not? Yes or no? So this means that only an observer can feel that the pseudo force is working in that frame itself. It cannot be calculated according to the other frame. Are you able to get me? And this is the meaning of pseudo forces. Are you able to get me? Here many people will do a mistake. What they will put, they will directly go into the pseudo force as 2 into 5. But that is not true. Pseudo force is of the frame itself. Are you able to get me? What is changing over here is you see that displacement of the cart in 2 seconds is how much? 4 meter. But displacement of observer A in 2 seconds is how much? 10 meter. So there is some relative displacement between A and this cart or not? Say me something, yes or no? In t is equal to 2 seconds. So look over here. S relative. That is how much? So S relative, I have to find the force on 2 kg with respect to observer A. So basically S relative is going to be how much? Displacement of the cart minus displacement of the observer. Say me something, yes or no? Which is how much? Minus 6 meter. Means you will feel that, means what you are going to see? You are going to feel that this block is getting left out behind and you are moving ahead of it as your acceleration is more. Are you able to get me or not? So what you will see that this friction is holding that block till that relative displacement or not? Because the gap between you and him is how much? 6 meters on. Is that clear or not clear? Are you able to get me? Say me something, yes or no? Did you understood the meaning? How I told? This is my block, something is holding it up. This has traveled from here to here, 4 meter. And this another observer has traveled from here to here as how much? 6 meter. Sorry, 10 meters. So when I look into back side of that, what I'm going to feel that this friction hold this block till a value of how much meters? 6 meter, because I'm looking continuously back over here. Is that clear or not? So I'm going extra 6 meter and I'm seeing that this block is at rest with respect to me. Are you able to get me? Clear? So therefore here work done, if I write in second question, this implies that work done by friction with respect to observer A is going to be how much? This friction, although it is in forward direction, but displacement with respect to A is in backward direction, so it will become negative, and this will be how much? 6, sorry, frictional force, which is 4 Newton, to hold it, into minus 6, which is minus 24 joules. Same something is no? Clear or not clear? Is that clear? No, friction will be working in forward direction. According to pseudo force idea, friction will be working in forward direction. Is this clear? Is this clear or not clear? Understood? Third question. An observer at rest with respect to ground. Huh? How much joules? 16 joules. That is very, very good. Correct. Rayan, did you understood? Third question. An observer at rest on the ground at t is equal to 2 seconds. So observer is at rest on the ground. So this means that I'm looking on the body directly with respect to the frame or not. Same is something is or not. So if an observer is on the rest at the ground, force on the body is going to be how much? Simply 2, 2 into 2, which is 4 Newton, and that will be balanced by my static frictional force. Is that clear or not? And next idea is I can also find displacement of the car with respect to ground, and that is going to be half AT square, which is half 2 into 2 square, which is 4 meter. Now with respect to ground, the frictional force is working in forward direction, so therefore work done by friction with respect to ground is going to be how much? Simple, frictional force F static into displacement along the forward direction, which is 16. 4 into 4, 16 joules. Is that clear or not clear? Are you able to get me? Understood or not? So these were our some questions which we tried to do according to laws which we have understood till now. Is that clear or not? Are you able to get me? They are depth of proper physics. Means idea is that if I want to decide about pseudo force, I'll talk about this pseudo force in little bit great detail. How do we write pseudo force? In reality, how do we write it? Okay, understand this frame of reference approach. Okay, let's suppose there is some mass m over here. Okay, and this is some S dash frame and this is some S frame. Okay, and there are two observers, right or not? One observer is over here, O dash, another one is O, right or not? So I can draw these position vectors of the particles or not. Got it? And then I can join like this. Same is something else or not? Are you able to get me or not? Look over here. This is what? Let's suppose this is particle P. So I can write R with the PO vector as what? R PO dash plus R O dash O dash O. Same is something else or no? If I differentiate it two times, I'll get what? Acceleration of PO is equal to acceleration of PO dash plus acceleration of O dash. Same is something else or no? What is this? Acceleration of particle with respect to S frame means ground frame. Assume that. With respect to ground frame, and APO dash is what? Acceleration of particle with respect to O dash frame or moving frame, you can say. And this is acceleration of moving frame with respect to ground. Are you able to get me or not? Say me something, yes or no? Now, let's take a scenario. See, first thing, S dash is at rest. Achha, if S dash is at rest, then what will happen? Acceleration of O dash O will be how much? 0 or not? Say me something, yes or no? Now, this means that this is not accelerating. Means whatever acceleration you will observe of particle from the moving frame, same thing you will observe from the ground frame. Is that clear or not clear? Means this example can be studied like this way. Like there is a road. Okay. There is a tree on that. Got it? And on that tree, there is a monkey who is sitting. Okay. With telescope in his hand. Or not? What thing? Telescope looking on a road where a car is going. Where a bus is going. Wait, not car. A bus is going. Okay. And this bus is going to do something, and there is one observer whom we are going to observe, and another particle is there who is experiencing. So this is observer B and this is observer A. So look over here. If I say this car is at rest, okay, then whatever the monkey, whatever thing this guy, this girl is going to do, same thing monkey will observe and same thing this observer B will observe. Same something, yes or no? Correct now. So then what? A and B, same observation. Switch off the mic. Is that clear or not clear? With respect to NB. Now, second case, if the car is moving with constant velocity, if the car moves with which kind of velocity? Constant velocity. Now, what you are going to see? If I look over here, still, so look over here, see this. S dash is moving with the constant velocity. Mathematically, what will happen? That still my acceleration of O dash O is how much? 0 or not? Say me something else. Acceleration of O dash O is how much? 0. So as the acceleration of O dash O is going to be 0, then body will not feel the pseudo force, na? Arey yaar, say me something yes or no? Means you are saying that the body is not experiencing anything. So as it is moving with constant velocity, B will see that this person is at rest. But what A will observe? A will see that this both of these guys are moving with constant velocity along right hand side or not. Say me something yes or no? B rest, A moves with constant velocity along right. This is what A is going to observe, correct? Say me something yes or no? Now, but A will see, means let's suppose if B sees that this body is at rest, so with respect to A, it is moving with constant velocity. So net force is again on this body is how much? 0. Means with respect to B it was 0, with respect to A it is also how much? 0. Means what happens if the frames are not accelerating? Means if the frames are at rest or if the frames are non-accelerating, with respect to different observers, forces present on the particle remains same. Forces present on particle bulk, what it remains same. So this is why these two kinds of frames, these two kinds, okay, this kind and this kind, Both of them are called as inertial frame. Are you able to get me or not? Why? Newton's laws are intact with respect to different observers. Is that clear or not clear? Rehan, clear or not clear? Abhiraj, clear? What happens? Forces remain same. I'm not talking about motion. I'm not talking about the direction. My what remains same is their forces. Is that clear? Are you able to get me? Now, when you consider next scenario, if S dash is moving with constant acceleration. If S dash is moving with which kind of acceleration, Malak? Constant acceleration. Now, if S dash is moving with constant acceleration, you can see that there is a, let's suppose I wrote a vector O dash O is something like n naught. So what you saw means you can see that acceleration of particle PO is written as acceleration of particle P with respect to O dash plus some a naught vector or not. Say me something, yes or no? Reply me, yes or no? So see that. See. Oh, set. 1 minute. Let me remove this space. What I'm saying is that this time the car is accelerating on the ground. And with respect to observer B, this one is at rest. What you're going to see that means, see, look over here, means this particle was at rest inside the frame. If it is at rest inside the frame, then a PO dash will be 0 or not. So with respect to the ground, what you are going to observe, you are going to see that this body is still accelerating towards right hand side. Are you able to get me or not? Say me something, yes or no? So if with respect to B, if the car moves with acceleration a naught along right, so with respect to B means ground, so with respect to A, you are going to see that observer accelerates with same acceleration as of frame, correct? I mean, this monkey will see what this person is also moving with same acceleration along right hand side. Are you able to get me or not? Say me something, yes or no? But what happens with respect to B? If I write a PO dash, if I write acceleration with respect to PO dash, then the formula changes. It says that acceleration of particle with respect to ground minus of a naught means suddenly there is a presence of extra acceleration on the particle or not. Say something, yes or no? Are you able to get me or not? Let's suppose even if it was at rest with respect to ground, you saw that there is a minus a naught in the frame or not. Say something, yes or no? Where a naught is what? Acceleration of the frame. Are you able to get me or not? So what you saw that there is a presence of extra acceleration on the particle with respect to observer on the frame itself, not from the ground observer. It is present with respect to which frame? Frame itself. So therefore, the force equation changes and it is written as FPO dash is written as FPO means normal forces which are measured minus of m and naught. Extra force appears, and that this is why this force is called as pseudo. Say me something, yes or no? Are you able to get me or not? Clear? So idea is that, Balaks, that these forces are appearing, this pseudo force appears means if I see with respect to B, my pseudo force appears. With respect to C, observes that particle is feeling an extra force in back direction with respect to car. Got the idea or not? Is this clear or not clear? Understood? This is the meaning of pseudo forces. So this is why when it starts to accelerate, we call this as non-inertial frame, such that our NLM can be valid in this frame. To make NLM valid, we consider it as non-inertial. Are you able to get me or not? Clear? So this was our concept till now, and we'll move next to this. We'll keep it till over here. Tomorrow, WP morning, we'll have tomorrow gravity and spring force. Acha, tomorrow is spring force you guys want. Tomorrow we'll deal with the spring forces. Morning just spring forces. Is that clear?